MQTT is a simple, flexible, and popular ISO standard communication protocol that can be used for almost any IoT application imaginable. But there's always room for improvement, especially in demanding fields like industrial automation. The Sparkplug specification for MQTT adds more structure to the standard MQTT architecture so that it better supports industrial IoT applications. The main enhancements are to state management, the topic namespace, and the payload format. In this video, I'll go over these differences and how they apply to the use of MQTT in industrial automation. The Sparkplug specification adds these requirements to provide the extra structure that MQTT needs to be a powerful tool in industrial conditions while still being an open standard governed by the Eclipse Tahoe project. This means that it is not an entirely new messaging protocol, just a more strict implementation that is built on top of MQTT, so the structure and functionality of MQTT applies to Sparkplug as well. If you're not familiar with MQTT or the publish-subscribe architecture, check out our other videos. In this video, I'll be working with MQTT and Sparkplug for communications between my Windows computer here, connected to the Opto 22 company network, and this edge programmable industrial controller, the Groove Epic, which has a cellular modem attached to the back for outbound-only communications, using an unknown IP address provided by the cellular network carrier, in this case Verizon. Now with both of these devices online, there are a lot of different interfaces for Sparkplug, and I'm going to start with the Ignition Edge platform by Inductive Automation, which is running on this laptop. So let's dive in and look at that now. I'll start by navigating to my local computer and going to port 8088, which is where Ignition Edge is running. I'll go ahead and sign in with a user I've already created. Now I can go ahead and keep using Ignition for another hour because this software is free to download and use for up to 2 hours at a time. From here, I'll need to configure the MQTT server or broker that I'll be using for this video. I'll do that in the Configure tab under MQTT Engine Settings. There's a separate tab here for servers, and I can go ahead and create a new MQTT server. This is going to be the secure Opto broker. And it's sitting at SSL because it uses the secure sockets layer, and it's at chariot.groove.com. Also, since it is secure, I should use port 8883 instead of port 1883, which would be the insecure port. I'll make sure I set the server type to Chariot and put in a username and password for the encryption. Finally, I'll need to upload the certificate required for encryption, since again, we're using SSL. With that done, I can create the server, and we can see that it's already connected. Now with that all set up, I can go ahead and launch Designer, the Ignition Edge desktop application. I already have Java installed, so I can go ahead and launch it. Once it loads, I just log in again. And then after I select a project, right away I have access to the tag browser. And here, under all providers, there is the MQTT Engine Edge nodes, where you can see there are already many devices. These are devices connected to the Chariot Groove server and transmitting their data over MQTT and Sparkplug. I only just configured this server, but already all these devices are showing up. But what I don't see in this tag browser are the Groove Epic tags coming from this device here, so I'll need to set up Sparkplug. To do that, I can use this onboard screen and use the Sparkplug menu. So just hit Configuration and I can go ahead and start filling in the device and broker details. Here I'll add an MQTT broker and set the broker URL to be the same secure sockets layer server that I have over in Ignition Edge. So I'll make sure to preface it with SSL and put in chariot.groove.com. And then again, since it is secure, I'll need to put in port 8883 since that's the secure port. Next is the client ID, and I want this to be unique, so I'll make it something like Workshop DC013. Also need to put in the authentication user and password. And again, since this is SSL, I'll need to point to a certificate to make sure I can get past the encryption. While I'm here, note that I have this keep alive timer set to 10 seconds. I won't change it, but just want to point it out while I'm here. Now, with the broker set up, I can go ahead and put in the device details. I'll make the group ID Opto22 since I want it to show up in that folder over in Ignition Edge's tag browser. I'll make the edge node ID Groove Epic Workshop, since this is the Groove Epic associated with the Studio Workshop. I can leave the primary host ID blank, but I should give it a device ID. I'll make this Epic PR1, since that's the product code for the Epic processor. And that's where this device data is originating from. So I'll put that in, double check my settings, and hit save. Once the configuration saves, it'll prompt me to start the service. And then after just a few seconds, it'll report back that Sparkplug is running. So with all this done, I'll hit save, and I just need to go back into Ignition Edge and refresh my tag list. And right there, under all providers, the MQTT Engine Edge Node's Opto22 group has a new device, Groove Epic Workshop. All this data propagated through from the Epic and filled in this folder structure. So here I can see that I have my Epic PR1 device with strategy information, I/O data, numerical tables and variables, and all sorts of data here. There are many different internal tags now available, the panel light states and panel temperature among many others. You can even see the panel temperature steadily increase if I hang on to this temperature sensor. And then as well as read information from the Epic, we can also use Ignition Edge to write data, since Sparkplug is bidirectional. One of the numeric variables you see here is tied to the panel LED rings, a boolean to control the state. If I check that box and choose to enable writes, there, we can see that the panel LED has turned on. And back off again. And we did this without knowing anything about the cell modem, opening any ports, or changing any firewall rules. Also note that I got access to all of this right away without having to type in the tag name or path. The tags in the Epic are the single source of truth. They propagate all the way through the system without having to type a single character, without needing to poll any of the devices, and I can still see it all without waiting for any tag to publish new data. The current state of the data from each device is always known. This statefulness is different than most poll response systems and is also different from the retain flag, which is natively supported by MQTT. With a poll response system, you poll the device for data and then have to poll again to see if it's changed, but you may get a copy of the same data. MQTT's publish-subscribe system reduces network load by only having the client send data on change, so the current data must be the most up-to-date, since anything newer would arrive and override it. To deal with new subscribers, MQTT allows messages to be retained by the broker and sent out as soon as someone new subscribes. But if that source device has already been disconnected, there is the downside that stale data can get delivered. So to make this more robust, Sparkplug also enforces the last will and testament messages that get published by the broker when a client disconnects without warning. This last will and testament disconnection message relies on a very small heartbeat check between the broker and its clients. Specifically, that heartbeat is based on the keep alive timer that I've set to 10 seconds on my Groove Epic. So now, if I disconnect my cellular modem from the Groove Epic, then right now the broker is counting down from 10 for as long as it does not receive a heartbeat from the Epic. After that time has passed, there we go. I can see the tag go red, so the data must be old. I can still see the state of the data, but I know that no new updates are being received. Sparkplug is able to do all this while still keeping the network load low, since each heartbeat is just a 2-byte packet. And then since I've plugged it back in again, it'll come back online, and there we go. I'm getting fresh data once more. This setup is crucial for industrial IoT since acting on old data can be potentially disastrous. And with Sparkplug, we're always informed about the state of the connections. So all of this information has to come from somewhere. And in particular, it comes from the forced use of birth and will messages, descriptive topics, and a more advanced payload. In most MQTT systems, the payload is simply unmanaged text, but Sparkplug does things differently. Instead of plain text, Sparkplug requires that each message be formatted in JavaScript object notation, or JSON, with specific properties set. While this may sound limiting, it's much better in industrial applications. To see what these JSON payloads look like, let's check out another Sparkplug-compatible client, MQTT.fx. In MQTT.fx, I already have the broker set up since it's the same as in the Groove Epic and in Ignition Edge. I'll go ahead and connect and subscribe to a topic. To find out what topics are being published to this broker, I'll use the MQTT.fx feature to scan topics, which will build up a list of topics from the broker in this window here. One of these holds the Groove Epic workshop data coming in from my Epic PR1. You can see it right there. I can subscribe to that directly, or I can type in what I know about the topic namespace. The first topic is the message namespace type, which can be a single level wildcard plus. Then we have the group ID, which for me is Opto 22, then the specific message type, which again I'll make a wildcard so that I get all message types. Next, we put the edge node ID, which is Groove Epic Workshop in this case. Finally, I'll follow that with the multi-level wildcard to get all subtopics of the Groove Epic Workshop. With all that entered, I can hit subscribe, and right away I can start seeing my data come in. I'll mute this subscription so that we can take a look at just one message. Right now, the payload is not readable at all, but it's not because they're corrupted. Rather, each Sparkplug message is actually encoded, and MQTT.fx has a decoder with support for Sparkplug payloads already built in. So I'll go ahead and enable the Sparkplug decoder. Now we can see all of the characters as they should be. The particular encoding Sparkplug uses is Google Protocol buffers, or protobufs. These efficiently encode structured data to be even more compact. These help keep network load low without losing any data, so that Sparkplug maintains the MQTT objective of having a small network footprint despite these additional features. Now, with this payload decoded, I can see the JSON information, but I can't see the structure very clearly. So I'll copy this information as plain text and open PrettyPrint, which is a simple and common plugin for reformatting text data that is in the JSON format. When I paste this in, I can clearly see all the different segments. PrettyPrint just adds white space to separate out the parts of the message. In a typical MQTT message, there are no requirements on either encoding or on format. You can just send the message true if you want. But with JSON, that true must be part of a key-value pair, just like this temperature value right here. It also must reside in curly braces, which this entire message does. But Sparkplug specification in particular doesn't just send temperature as a value in JSON format, it also includes a lot of other information. Here we've got the timestamp, we've got the quality of the point, there's also the data type for the metric, and several other metrics included as well. While we get all this extra information with Sparkplug, it's still really efficient due to the Google protobuf encoding that we just saw. The other thing is that this information gets resent if any damage is done to the folder structure. For example, if I bring open my tag browser, and I bring open MQTT.fx, if I go ahead and clear this topic window, and then attempt to make some kind of change to my tag browser here, for example, I could attempt to delete this Groove Epic Workshop, we can see right away a whole bunch of birth messages came through as these devices re-establish themselves. And if I refresh the tag browser, under the Edge Node's Opto 22 group, I can see that Groove Epic Workshop has come back. I wasn't able to delete it because the workshop is the single source of truth. Sparkplug takes the benefits of MQTT and uses this extra information to create a more connected, more structured system that is extremely powerful in industrial applications. To find out more about Sparkplug, Ignition Edge, or the Groove Epic, check out opto22.com. For more details about Sparkplug, check out the cirrus-link website. Thanks for watching.
you.